Okay, thanks everyone for joining in. First of all, let me give the credit to the Big Data Club, which give the possibility to us to make this presentation. We are Cherrybit. We are actually me and Chai Botta. I'm Antonello Fodde. We are two members of the team of this startup. In this presentation, we will see something that is deeply related to the thing that we do, actually, because our organization is working with data, and I think this the core capabilities are there thanks for our experience of processing and retrieving data, but we will see deeply afterwards. We called the presentation being a data-driven fintech, which we are. And just a few notice, we set up the meeting to give you the possibility during the presentation at any time. You should see the link on the top of the slide. And that link, if you go to that link, you will be able to ask any question anytime about the content regarding the topic, of course. And in the last section of the presentation, we will try to answer as many of them. The presentation will last, I think, half an hour. We'll see, and then we will move to the Q&A session. This is the agenda for today, and I will start, and then I will give the word to Chai for his part. But first of all, the company. So who we are? Well, the company was born with the name of Cherry SRL. The aim was innovating a market, which is called NPL, or more in general NPE, which stands for non-performing loans. Probably you are familiar with this term. For those that are not so familiar with the term, basically this market aims to propose a solution in order to help this exposure, which usually what's happening is that a person or a company in general is doing a loan with a bank, and something happened bad, and so in some situation this person or company cannot fulfill and cannot give back the money, so it creates a debit, which is a bad thing for the bank. And so many company, and this one created an open market for this type of credit, which will give the possibility to company like us to have something to propose, which is actually what we are trying to do is innovating. So we are a tech company, and we are trying to use our capabilities, technology capabilities, to create solution for this type of market. We will see what we do, actually. And the first thing that we have done is creating this product, which we called it Cherrybit. Cherrybit was our first project, and then actually it moved as an identity for the company. So that's why in the front page we put Cherrybit. Well, Cherrybit is like let's see. First of all, it's like an avatar, this girl, as you can see, which stands for a platform. So we've developed in this, I think, last year and a half, a platform which gives the possibility to have an insight and recover data, and let's say doing estimation that will help a lot people that are working in this market, in the MPE or MPL. And so what we do, thanks to Cherrybit, we are being able to connect many source of data in Italy. We are working. And so, for example, what can be helpful in this world, recover all the, let's say that the subject is a company, is core to recover all the data on the status of the company, which has registered. Is the company active still? And many other things. For example, all the data that is coming from the cadastral, and so all the real estates that are associated with that company, or in general, all the information about a person that could be our subject of analysis. And so the job associated, the age, and so on. Other things that are useful, very useful, legal cases. So we also aggregate all the information that is coming from the courts in Italy. And some other things that I will not go deep to all the data that we manage, because the aim of this presentation is like giving the idea of how to handle many data as we are doing right now with the technology. So very briefly, what we do, actually, the product starts with an input as our client has some data, for example, a list of debtors, identity. With this, what we can do is using our platform to go into the web and also aggregate some data that is coming from, let's say, semi-private database, which we are registered, recover the data, validation of the data that we are receiving, reconciliation, we will see deeply after that, and reconciliation is like tied to the data model. So actually, you can think about the data is coming in one way, of course, in some format. It's really important to give a representation, a good representation of all the data is coming in your platform. We will see them. So reconciliation, our data model that we created. Visualization, of course, because you are using all the data and you are also give the possibility to the person to show the data in the right way, of course, like some KPIs that is really important for evaluating a portfolio in the MPL world. And then, of course, the most important thing that we think, the cherry picking, because all the data, the aim is only this one. I need to have the possibility to understand which credits are better than others. Because if the credits are a lot, I need to prioritize the one that are good, of course. And leave the bad ones at the last position. This is the product, and this is the service as we propose to our clients. So 3 steps, basically. First one, reconciliation. So we take our input data, then we do this portfolio profiling service. So we enrich the data, and then we have another service which is called live update. So we can think about, okay, we do the reconciliation at one time. After that, it's important also to keep updated all the data. So that's why we call this live update. So we give the possibility to our client to keep all the data updated. And then what I was saying before, recovery data and value. So I can present the result of all the analysis, and I can say, okay, to our client, this is the value of your portfolio that I estimated, and then I estimate also when you will be able to recover your credit or your debtor. But who we are? Please, can I ask to turn off the microphone? Okay, thank you. And who we are? We are this team, a small team, but is a really good team, let me say. We have all, or most of them, background in technology. So as you can see, I'm Antonello Fodde, and we have also here Trey Botta, and other participants, Luca Bonascina and Giacomo Fava, and the junior one that are the new joiners, Katia Gatti and Andrea Tomasoni. And then our CEO, of course, Mara Di Giorgio, which is a really important piece of the team. It has the background of the market, of course, because we started in this market and doing stuff for this type of business recently. And so we need, I mean, at the time we had the need for deep help. So that's why Mara was very important. Also still is very important. And okay, so what we're going to do right now is give an idea of what for us is important, and starting from the we think tech building blocks, which we called for being a fintech startup. So if you are planning to do your startup in technology, of course, we think that there are small building blocks that you need to keep in mind in order to make good product, of course, related to technologies, something like building some software to doing stuff. And first of all, of course, is the technology stack, which is a really difficult topic because in software engineering we had so rapid changing of the technology stacks, and you need to evaluate, let's say, the right one that can suit your business. It's not so easy, but in general we have trends, hopefully, that we can follow. And of course it depends also it is a trade-off between the person that you can hire and the skill that you can get for the person for the implementation of the stack that you select. And then, of course, cloud. I think that this is very important, also common right now, nowadays, but is a key point because it can help you a lot forgetting about the hardware maintenance and also rely on some good product that cloud provider nowadays are presenting to you and offer to you, which I think is the only option right now, is getting all the stuff that you have developed or you are developing or planning to develop to the cloud. And then, of course, data modeling. So all this presentation will focus on the data. So data modeling, data processing, data moving around, and data processing in general. So we will see how this is very important, of course, for, in general, technical company, but more deeply to the ones that are working with data. as we are right now. And then some other stuff, but it's very important in general in software engineering, like architecture. Here, architecture could mean infrastructure architecture. So all the pieces that you have developed, software, microservice, and the way that you tie everyone, and the way that you give the possibility to communicate to all these service in between, but also could mean architecture in the software. I mean, if you're writing code in a small application, but also a big application could be, it's very important to give an architecture, abstract architecture of your code or your application. And of course, software is done with code, so it's really important to rely on some stuff as some tools that helps you to keep your code quality in a high level. Usually these are called some linters for static analysis, but also other complicated tool which gives you the possibility to keep a high standard of your product. Test automation, really hard to do that. But in general, you can think about scaling your application or your software, and at some point not facing the problem of testing your application after a modification. For example, you are modifying some functionality that is core to your business, but every time that you touch this piece of software, you know that you have to test everyone and every step of your flow, for example. And this is a really big problem. As you are scaling, you are increasing the time that you are spending in testing. So the solution is not for the first step of your evolution of your software, but at some point, as early as possible, you need to start to implement your testing automation environment, which can save you really sometimes, because it's really hard to sometimes spot the problem, because as you are developing and you are testing at the same time, sometimes it's hard to see objectively some problem that can happen. So testing automation is really helpful in this world. And then some harder tool like CI/CD, which stands for continuous integration and continuous development, which is a DevOps thing. And the aim of this one is like increasing your productivity as you are developing and you are creating software. And then, of course, when you are going online, you are developing and you are deploying your application, of course, is core that you have some tools which you can alert you that you have a problem in your application, something happened, something bad happened. So, for example, you didn't think about a situation where something could be down is not available in our language, so something bad word could happen. If you are an alert or some spot after an alert that you can analyze what happened and then react to it, is really important. So that's why it's also very important to select the right tools for logging and monitoring of your application. But after that, I want to focus about the data modeling, as we are talking today about data, let's focus on one of these pieces. So data model. I would like you to present our official first implementation of our data model, which of course is really simple, but you need to start from some point. And so we're all started. As you can see, these are our implementation of this first version, and this is the graphical view of what our database at the time was. So as you can see, the building blocks of our data model are there. For example, we have some general representation of our subjects, which are company or person, as is called entity in our data model. And then we have the representation of all the line of credits, which are a representation of the single credit that some debit or credit, debit, of course, for the debtor and credit for the bank, for example, and the value of the line of the credit, of the line of credit. And of course, in this market, we could have associated some guarantees for the credit. And so we have the list of the guarantees for the line of credit, and so on. Guarantors, guarantee type, but also we have all the data about the real estate. So the properties, the physical property of the entity, as we call it. But this one is really, really simple model. So what happened? From here, we went here. Okay, we are still there. We expanded some information about our real estates and some other linking in between, but most of them are still there. And then I said, oh mine. So here the concept is you are evolving constantly your data model, and so you need to face some problems and some challenge, because it's really hard sometimes to solve this problem. So as you can see now, and this is the last step, sorry, I forgot it. So this is the last implementation of our data model. So what we can think about, we can select the things that we, from our experience, are really core to evaluate when you are facing the development, the design of the data model, of your data model. First step, of course, I've said, is the design. Design is key. So keep in mind, this is important, so you need to understand it, and you don't need to underestimate it, because it's very important, because a good design could save you afterwards. A bad design at the start could cause some really big problem, because you will see there, as your data model is constantly evolving, you will need to face something that is called data migration, which is a really hard stuff to do, believe me. So the design is key. So if you are able to anticipate what you think that you will change in the future, and then make your choices to make a model that could be extended, is the best thing that you can do. But at the same time, it's also very important to keep it as simple as possible. Because of course, in general, I say that over-engineering a solution is as bad as under-engineering a solution. So it is here a trade-off about something that you need to expand some future, but at the same time, you want your model to be as simple as possible. Then I said, open to change. So you know that your model will evolve at the time. Just because you are learning something new that you didn't know at the time. And so maybe, I didn't know that a relation could be there for the ownership of the real estate in between, from the guarantor to the debtor and so on. And so you need to change at some point your model. And so be brave, because this is really hard stuff. And it's not avoidable. So you need to prepare to do it, which can cause a task which is really tough to face, which is database migration. So I put here master database migration, because the migration is stuff that is really standard in an organization. I mean, not so frequent, but it's possible that sometimes you need to evolve your data model. Then you need to migrate all the old data, which you're not going to throw it away, of course, and move it to the new format, which is the new data model of your organization. I also mentioned that you helpfully a lot when your model is growing, is getting bigger, to make a graphical view of your representation. So make a graphical view and keep it updated. The last point is good data, which means in general is better to trying to structure your data, which means give a structured representation, for example, for a field of your database. All the structured data is important, because after that you have a good structure, you can extract the right data, the useful data from your, for example, database, which is the implementation of your data model. Try to give a clear scope of all the components of your data model, of course. So it's also important a good naming for your table of your component, for all of your fields. Try to imagine that someone that didn't know anything about your data model can see the graphical representation of the data model. Most of the topic, the content is clear to him. So if you see line of credit, guarantors, and so on, you understand that this piece is representing the line of credit of the debtor that could have a guarantor or a guarantee associated, and so on. And of course, all of this data at some point needs to flow in between your service. I mean service and services, because most modern architecture are done in the so-called microarchitecture, which means that your application is not one, is composed with a lot of microservice, the so-called, which stand for a micro application that is so tiny, that has a clear scope, and that usually is developed to doing one thing in general. So in the micro architecture world, one of the most common problem is make all the data and all the service communicate in between, which can lead to some problem, of course, because we are in the world of software and communicating means internet. And a lot of bad stuff can happen there. And also, you, of course, need to have some mechanism to communicate efficiently and pass the data between your services. Which brings here to our super simplification and introduction that will be extended by Chai in his presentation. But just to give you an idea of what could be a solution and usually is a solution in this world. So let's start about thinking to this service, which we call producer. So the producer is a component that could ask some data to another, for example. And the way that this methodology is sending a message, okay, general message, which will goes to a component that is called message broker. A message broker is, of course, an application that is, the aim of the message broker is handling and orchestrating all of the queue that he managed. The queue is the container of all these messages that accumulates all the messages, waiting for them to be dispatched by the message broker. Sometimes, at some point, the message broker will need to push the message to the target service, which is called consumer. So the producer will produce the data and the consumer will consume the data. This solves a problem which is called back pressure, because if we eliminate the message broker in between and we push the message from the producer to the consumer, we have a lot of problems. For example, the message could fail, the dispatch of the message could fail. Or maybe imagine that the scenario where the producer is really rapid and produce a lot of messages, but you have a tiny service that can handle just few messages at a time. And so you have a mechanism which need follow to process all the data that is coming to the consumer. In a way, you can accumulate all the message in the queue and then decide a rate for the message broker to push the message to the consumer. So this is the rough explanation of what could be a solution of the data flow. So the flowing your data between your service. But at some points, of course, you need to make it available to the crowd. So imagine that you have a client which wants to integrate to your service. So you need to export sometimes this data in some way, which brings to the next topic, which we called move data to the wild. For this one, I will give the word to Chai.
Yes, thank you, Antonello. Can you switch off
the presentation? Just one moment. Okay.
Okay, thank you, Antonello, for the introduction. So I would like to talk to you about move data to the wild. So since we got a lot of data from different services, different sources, we would like to move the data. And this is a very important step for our overall architecture. But before deciding how to move data, I would like to talk about actually the base. How we are designing actually data flow. So which are the decisional components we're picking in order to start one data flow. And I would like to start with the 5 questions usually asked in journalists, for example, in any information flow patterns. So let's start with the why. That's represent the need. So we are moving data for some reason, and from one source to the destination, one database to another one, from one system to another, and this is should be accomplished by answering a question they need. So movie data can be because we want to perform some risk assessment over the data because it provides business value. In our cases, for example, we are getting data from different systems to our for business value, provide additional value to the customer. Then once we get the need, we can define the kind of job needs to be done over the data. So the kind of job can be as well, we want to crawler or get data from some website, stream the data, perform some process data, or securing data. That's can define. We can define example like encryption job or replicate data over databases. When the job should be done, there are different kind of data flow, and all data flow we should keep in mind when execute this process. We may want to synchronize our CRM system, the company CRM system, daily basis, or we want just to start some data processing on demand based on API calls. So let's say, for example, front-end calls API, or ASAP when data is available. And talk about data, we should understand well where to move our data on and where to store our data. So pick the right storage, called hot storage. If we should cache our data, or as well use a more classical storage type, so NoSQL databases, document base, or SQL Server, for example. And the last one, when all the previous are well understood, we can pick the right job. That is picking the best tool, let's say best agent to perform our job at the time, at the place, in order to answer our original need. So that it can be, this is actually where our code, application business logic code is located. And it can be on a cloud function. It can be as well a script bash or shell file to start, initiate the process or to perform the job, or a standalone application invoked by REST API. When all these 5 questions are well answered, well understood, we can finally decide how we want to achieve our data flow. And means the how can be answered by picking our own programming languages. So the one you are more familiar with, for example, if you want to use one framework instead another because you are more familiar or proficient or want to learn. As Antonello suggested before, by this time it's absolutely necessary to understand and be familiar with cloud provider, cloud technologies. So I propose 3 of the main cloud provider solution, and I have a personal experience mostly on Azure Cloud. In the last 3 years, I started working with Google Cloud, and at Cherry, we are focused on Google Cloud. You can then define how you want to design your software, picking some patterns, some principle, just in order to have a best code quality and best to improve your product, and also a more testable, solid code means also best data flow and more secure data flow. You can pick then the infrastructure where your code will run, and it can be on-prem virtual machine, local host or some architecture more classical based on cloud cloud IaaS, infrastructure as a service, or platform as a service. There are services such as SQL databases. You just use the SQL connection and not thinking about installing the SQL and managing everything from MySQL Server, for example, but just using the service and not taking care about the replicas, the connection, and whatever. Or if you're familiar with Docker, I strongly suggest you to start studying Kubernetes as a container orchestrator. So containerizing your application, of course, can improve your code, so your business logic portability from one system to another, and as well it brings you additional advantage. And finally, of course, talking about data, you need to understand your data model, your schema, decide the partition, everything related to data quality, consistency. But let's getting back to actually data flow. I would like to suggest you two approach. Actually, they are the one we are implementing Cherry. The main goal, of course, is we have a data source and a data destination. The goal is to bring the data source to data destination. It can be just a copy data from one source to destination, but most of the time it's just moving data from a source we don't have control over. For example, scraping some website or getting data from CRM. So most of the time we don't want to develop CRM, but we need business data inside CRM system, and that's why we need to connect to the CRM database and move just the modules, the components, piece of data we need to our own data destination, where we have full control and want to perform additional computation and processing. The simple approach is also the one Antonello said before, direct data storage. We can build our small application with some data logic inside. Application can be as well as a script, connecting to the data source, and then just copy some data, performing some business logic, and then storing data directly to the destination. This is a good way, say, for if you want to move few data for some testing. You can as well improve this step by calling API, so a third-party application, another application you are doing to perform additional logic. This is likely better because you are splitting business logic into pieces, and you can through the API can be invoked by also different applications. So you can store different data in same databases because your API doing this job. So your first application can be your application, a script, or whatever else. And you can change this component, why the API connect to your data destination can be kept the same. Or the other approach is you decide to stream your data. There is, of course, one entry point application connected to data source, but this application is not connect directly to your data destination, but to some intermediate components. Let's call service bus or message broker. Here I list Kafka for stream platform, data stream platform, or PubSub, it's just a more classical message broker technology base. And then we need when we want to stream data, we need additional components called subscriber, where inside the subscriber we can actually have our data logic, business logic custom, and the subscriber are the one in charge to connect to this intermediate middleware, so this message broker service, and the subscriber are the components in charge to publish data to our final data destination. So So comparing the two different approach, of course, the data streaming one is more complex, but there is a huge advantage because in the direct data storage, the data might get lost. So you can lose messages, lose data because let's say the API can fail or because the connection to database may fail, and by this way you are losing your message forever unless you restart the process from the beginning. On the other side, data is somehow guaranteed to be received. This is because the publisher, since the publisher is able to reach your intermediate layer, the one you read, the PubSub or Kafka, you are guaranteed that data will be delivered at some time. Maybe not now, because some subscriber may be down, because the subscriber cannot connect to your data destination, but your data from your data source is kept somewhere in the cloud, somewhere in this middle layer. So it will never get completely lost. That's why we never choose the direct data storage, but we went for a data streaming solution. And there are different way to streaming data, and with some advantage, one pro and cons. The classical most used, I guess, is the push approach. That is, the application is connect to the data source, the publisher application. Then the application publish data to our intermediate layer, so middle layer. This is a PubSub, Service Bus, or RabbitMQ. They are actually message broker. So you can think of for a small application able to receive your message and store your message somewhere inside their memory and keep your message there until some subscriber with some data logic, whatever, ask for the data. And in the push approach, actually, you can see the arrow going from the red square to the subscriber because it's the PubSub components or RabbitMQ, so the intermediate components is in charge to send data to anyone, any application subscribing to the intermediate component. So as a subscriber application, just subscribe, and anytime new data comes to the RabbitMQ or PubSub components, this message is automatically sent to the subscriber. The pull approach is a little bit different. That is, of course, the publisher send message to our components, Kafka. This is our data streaming technology based on pull or polling strategy. And actually, is not Kafka components here is not in charge to send any data to the consumer. So the consumer is like the subscriber, but the subscriber, the consumer itself, will pull new message from Kafka. So anytime, let's say the consumer just are connected, of course, to the Kafka intermediate layer as a, let's say, sort of database, and then at the scheduled time, just polling, are there new data for me? Are there new data for me? And if there are new data, the consumer itself will get the data they need for the job done. So data push is actually performed with acknowledge. So the technique to send back acknowledge, that is when RabbitMQ, the intermediate layer, send message to a subscriber, the subscriber has to send back acknowledge. That is, I received the message. You can flag the message was completely received. So this is ensure that if RabbitMQ does not receive the acknowledge, we'll try to send the message again and again. That's guarantee the message will be for sure delivered to the destination application. As well, in the pull pattern, there is also the acknowledge pattern. That's the consumer send back message to Kafka, ask for a Kafka message, and Kafka is waiting for the acknowledge. That is, did you receive the message? Both technology you make use of a queue. That is kind of way to store information in a pile, but different is that using service bus technology such as RabbitMQ PubSub, so in the push strategy, messages are dequeue after acknowledge received. That is, they are not storing your messages forever, but once your message is received by any of the subscriber, the message is cancelled, removed from the intermediate layer. While in the Kafka, messages are, let's say, never completely deleted, because once a message was successfully pulled by the one consumer, the message itself stay on Kafka for a while. You can define how much time data should be kept in memory, and then but to process the next message, usually the offset to the message is updated. That's how Kafka is able to deliver one message per time, one after another. This is just one example of data stream architecture, in this case with Kafka. This is part of real application design we have somewhere in place. And as you can see, we have one producer application here, actually more than one producer application. The application itself is connected to some script function or service API that is our data source. And based on the data source, they can generate events over Kafka. And in the stream application, every time new data comes, we can generate one event on Kafka. And by using one producer, we can listen for this event and start some processing. That is, store data over some technologies based on data warehouse or data lake. In Google Cloud, they are called BigQuery or cloud storage. And at the same time, can stream data, that is, send small piece of data over other channel inside Kafka. And this small piece of data can be delivered to other application. Let's say in this case, the transformer application that is sent as well to in this case Mongo database. So this is our consumer application in charge to get all data stream components, small piece of messages, and updating the collection on MongoDB. This is NoSQL components. And why, for example, we have different data destination in this case? Because if we are using data warehouse or cloud storage as a long-term data storage, so here we are storing gigabyte of data with the scope to archive the data. In MongoDB, we are just storing small pieces of information, the one we select to our streamer, producer, consumer. And by storing part of the information in MongoDB, we can as well decide to expose this piece of information to external application, so to other system other than us. That is, we can open our data through API to our customer for further integration, for example, with the customer data. I hope this was not that complex. I know that's not that easy to understand. I will be happy to to hear to have some question from you to be more clear actually. And
Thanks, Charles.
yes,
Let's try something cool. I have a button which is saying present. We have 2 questions right now. If you want, in the meanwhile, to write down your question, follow the link on the top as usual, as I said before. And let me try. Not showing anything. You're presented. Sorry, try. Just one moment. Who is that? Okay, first question. Who wants to answer? Try or me? I mean, it's not easy, but in general, okay, our story about this topic. Of course, we are a startup, as everyone, I think. At the time that we started, we didn't have any revenue. So, of course, we have a kind investor that we rely on that support our project. And of course, as you are moving on with your startup, you need to face the problem of having a revenue. So that's why you need to evolve your product as soon as possible to get something back, like a revenue. So that's why you need to develop, for example, if you are developing a software, to develop incrementally your solution in order to, as soon as possible, have the possibility to sell your product and have a basic revenue, which will not probably cover all your expenses, but in general is a starting point to evolve. And then after some point is the best moment, I think, is reaching the cost of the company with your revenue. But of course, it's a general answer. I cannot really be the guy that has the bowling ballet for you. But our story is, as usual, I think, like this. And next one. Chai, this is for you.
yeah, kind of client do we work with? Clients, I guess you mean customer. We are working mostly with banking institutes. So since the banks are the one producing more NPL, no performing loan, so actually the one providing more loans to privates or to company, and once they are not able to get money back, the loans is transformed into non-performing loans, and they need to get some money back. So they need to understand how much money they can get back, and that's why they rely to our system, because we can provide them live screenshot of whatever or whatever are the debtors has properties or we provide screenshot of actually debtors recoverability. So see how much actually they can recover from that debtor, and this can be understood if you understand how many properties, jobs, or legal issue the main debtors incurs into.
Okay. Next one. Yes, we are doing right now.
Yeah, it's recorded.
Next one. Okay, are you playing on European expansion or sticking to Italy? Tough question. We will see. I mean, it's really difficult at the time because it's a market which is really specific from some point to the country that you are working on. But of course, our plan is trying at least to do something, not maybe all the thing that we are doing right now at the same way in Italy, but in general, try to apply some analysis that we do also outside Italy. At the moment, we are not working with Italian customers, but the market is big and actually is really present in Europe also. So why not? We will see. We'll see. Probably yes, in a few years. We'll see. And next question, let me see. Okay. Yes, let's keep this question to the last point, which of course is hiring. So let's see the others. Okay. You want to answer to this one, Shai?
Which sort are used frequent for big data project, or just like you share in your slides? So you want to know which software frequently used? Actually, I can tell you from even my previous job experience on big data projects with enterprise industries. One tools, very cool tools, is Databricks. I don't know if you're familiar with, but it's very cool tool for based on TensorFlow and Hadoop technology. You can really perform, let's say, heavy parallel data analysis and processing using distributed computing. So Databricks is a very cool tool. Actually, for most of our data analysis and processing part, we are using Python. And for our data flow parts, we're mostly going for JavaScript because it's very, very fast in terms to response and process a small piece of information at a time with a very high throughput.
You're welcome.
Do you have a data visualization? I see another one.
Yeah. Data visualization. If you mean some tools to visualize the data, of course we have it. We develop a platform that is the so-called Sharebit, which is a website, and that website gives the customer the possibility to analyze the data that we present to him. And we are using widget, which is collecting KPIs. We use graph. So we develop our data visualization platform. And it's one way that you can use the data that we are retrieving and presenting and also selling to our customer, which is one way, of course. The other way is, I don't know, in some integration like Chai presented before, some infrastructure of the company who want to get the data inside their database. Of course, we can integrate like with the technique that you saw before, explained by Chai, and others in general. Most common way is like exporting files like Excels. So the market is really hold on that sense. But yes, we have a visualization of the data, which is our platform that we develop. Do you work on dashboards for designing, planning, or in general? Okay, we use dashboard. We work in Agile, so our tool for working is Jira. So if you mean this type of dashboard, we use Jira as a methodology, Agile methodology and tool for working. If you mean dashboard in general, I would say yes. And also a dashboard which is very familiar between us is the cloud platform provider, which is Google in our case. So we use the Google dashboard for controlling all the product we have in our organization. And other lot of questions. Let's say the most interesting. We are a little bit out of schedule. Hiring. Yes.
When asking
Okay.
if you can show a sample, Anto.
Let's say maybe here something, try, because we received a couple of questions about hiring and internship. And as a startup, we are constantly keeping an eye on the crowd. So we recently searched new joiners to join our company, and we are constantly looking around for the right person. So in general, yes, we are hiring. Which role? In general, we develop software, so we are looking for developers in general, full stack developer in the web world, or as we are also working with data, some data scientist that is also interested about data analysis and in the way that, of course, you are writing some kind of software like using Python or something like that. And we have also another member that is Giacomo, which is the head of the AI, let's say. So we are doing a lot of stuff on that sense. If you are interested also on that kind of award, we also looking to hire at some point, maybe not really right now, but I will say in the following month, probably, yes. So also data scientists, if you are there, we are here. I prepare a QR code in general, which is a form that you can, in this way, submit your, your contact if you are interested about working with us. So just a couple of questions, like a small description of you, and then you will leave an email, and then we will contact you, which bring to the selection step we will see at the time. In general, we are also constantly evolving the way that we are selecting people. In general, also is depending on the level of the person. If it is a developer, usually we see the past experiences, the technology that had in the background, and sometimes we propose a code challenge, or in general, a general interview. So that's it, I think.